Good morning, students. We already start unit number 5, states of matter, gases and liquid state. We already discuss in this unit. So we already discussed up to ideal gas question in previous videos. So today we will discuss about the behavior of real gases or deviation from a ideal gas behavior, because all gases don't show ideal gas behavior, or they are not all are perfect gases at all temperature and pressure. So first we discuss about behavior of real gases or deviation from ideal gas behavior. So before starting the behavior of real gases, first we define the what is ideal gas or perfect gas. A gas which obeys the gas equation PV equal to nRT and other gas laws at all temperature and pressure. O gas which obey ideal gas equation PV equal to nRT and all the gas laws like Boyle's law, Charles law, Avogadro's law, Gale's law at all temperature and pressure. वे किसी भी temperature या pressure ਤੇ ਇਹ ਸਾਰੀ gases ਨੂੰ obey ਕਰਦੀ ਹੋਵੇ ਤੇ ideal gas equation ਨੂੰ ਵੀ obey ਕਰਦੀ ਹੋਵੇ, that gases are called ideal gas or perfect gas. But no gas obey ideal gas equation at all temperature and pressure. कोई भी गैस इदा दी नहीं है जी at all the temperature and pressure they show ideal behavior, but they show only ideal behavior at particular pressure and temperature, or you can say at low pressure and at high temperature they show behavior, ideal gas behavior. Otherwise at high pressure or low temperature or at any other temperature or pressure they does not show ideal behavior. Only they show at particular temperature and pressure they show ideal behavior. Otherwise they show real gases or deviation from ideal gas equation. So next one is deviation of real gases. So before starting the deviation, first we define real gases or non-ideal gases or non-perfect gases. The gas which does not obey gas equation PV equal to nRT and gas laws at all temperature and pressure. वो gases ਜਿਹੜੀਆਂ ideal gas equation ਨੂੰ obey ਨਹੀਂ ਕਰਦੀਆਂ, और Boyle's law, Charles law or Avogadro's law not obey at all temperature and pressure, only obey at particular temperature and pressure, that are called real gases or non-ideal gases. For example, oxygen, nitrogen, carbon dioxide, these all gases are real gases, but they show ideal behavior to different extent. Oxygen show ideal gas behavior at particular temperature and pressure, and nitrogen also show ideal gas behavior at particular temperature and pressure, and carbon dioxide also show ideal behavior but only at a particular temperature and pressure, not at all temperature and pressure. So let us explain their deviation from real gases or ideal behavior, deviation from ideal behavior with the help of graph. So we plot graph between PV pressure volume versus pressure, मतलब कि ਅਸੀਂ pressure volume versus pressure ਜਿਹੜਾ ਹੈਗਾ graph plot ਕਰ ਰਹੇ ਹਾਂ, ਕਿਉਂਕਿ ਸਾਡੇ ਕੋਲ ਕੀ ਹੈ P is inversely proportional to V ਹੁੰਦਾ ਹੈ, और PV equal to ਕੀ ਹੈ constant ਹੈ, because according to Boyle's law P is directly inversely proportional to 1 by V, और PV equal to constant means ਅਸੀਂ ਜੇ ਪ੍ਰੈਸ਼ਰ ਵੀ ਇਨਕਰੀਜ਼ ਕਰੀ ਜਾਵਾਂਗੇ ਤਾਂ PV ਦੀ ਜਿਹੜੀ ਵੈਲਿਊ ਕੀ ਰਹਿਣੀ ਚਾਹੀਦੀ ਹੈ constant for ideal gas equation. So according to this ਸਾਡੇ ਕੋਲ ਜਿਹੜਾ straight line graph ਹੋਣਾ ਚਾਹੀਦਾ for all gases, but here we see there is a no straight line for all these 4 gases. ਕੋਈ ਵੀ ਸਾਡੇ ਕੋਲ ਜਿਹੜਾ ਗੈਸ ਹੈ ਉਹ ਸਾਡੇ ਕੋਲ ਸਟ੍ਰੇਟ ਲਾਈਨ ਜਿਹੜਾ ਗ੍ਰਾਫ ਨਹੀਂ ਸ਼ੋ ਕਰ ਰਹੀ ਹੈਗੀ. ਸੋ ਬਲੈਕ ਜਿਹੜੀ ਲਾਈਨ ਹੈ ਉਹ ਆਈਡਲ ਗੈਸ ਇਕੁਏਸ਼ਨ ਨੂੰ ਓਬੇ ਕਰਦੀ ਹੈ. ਅਕੋਰਡਿੰਗ ਟੂ ਦੈਟ ਜਿਹੜੀ PV ਦੀ ਵੈਲਿਊ ਕੌਨਸਟੈਂਟ ਹੋਣੀ ਚਾਹੀਦੀ ਹੈ, ਬਟ ਇੱਥੇ ਸਾਡੇ ਕੋਲ ਵਿਦ ਇਨਕਰੀਜ਼ ਇਨ ਪ੍ਰੈਸ਼ਰ ਦੀ ਕਰਵ PV ਵੈਲਿਊ ਇਨਕਰੀਜ਼ਸ ਫॉर ਹਾਈਡਰੋਜਨ ਐਂਡ ਹੀਲੀਅਮ. ਜਿਵੇਂ ਜਿਵੇਂ ਅਸੀਂ ਪ੍ਰੈਸ਼ਰ ਇਨਕਰੀਜ਼ ਕਰ ਰਹੇ ਉਵੇਂ ਉਵੇਂ ਹਾਈਡਰੋਜਨ ਅਤੇ ਹੀਲੀਅਮ ਦੀ ਜਿਹੜੀ ਕਰਵ ਆ ਉਹ ਸਾਡੇ ਕੋਲ ਇਨਕਰੀਜ਼ ਹੋ ਰਹੀ ਹੈ, PV ਦੀ ਵੈਲਿਊ ਇਨਕਰੀਜ਼ ਹੋ ਰਹੀ ਹੈ, ਸਟ੍ਰੇਟ ਲਾਈਨ ਨਹੀਂ ਹੈ ਸਾਡੇ ਕੋਲ. ਉਸ ਤੋਂ ਬਿਨਾਂ when we increase the pressure volume of carbon dioxide and for methane, carbon monoxide and methane, it first decreases, and then after some when we increase the more pressure and it also increases and cross the curve. It means first they show negative deviation, after some time when we increase the pressure it cross the curve at particular pressure. ਉਹ ਜਿਹੜਾ pressure ਹੈ ਉੱਥੇ ਸਾਡੇ ਕੋਲ ਕਿਤੇ ਨਾ ਕਿਤੇ small extent ਦੇ ਵਿੱਚ ideal gas behavior show ਕਰਦੀਆਂ ਨੇ, but at all pressure they don't show ideal gas behavior. So what are the observation we conclude? from this graph, so hydrogen and helium, as pressure increases, the value of PV also increases. मतलब जिमें जिमें ਅਸੀਂ pressure increase कर रहे हैं उमें उमें ਸਾਡੇ को ਜਿਹੜੀ value of PV ਦੀ ਉਹ ਵੀ increase ਹੋ ਰਹੀ ਹੈ. Similarly for carbon monoxide and for methane, first show their negative deviation from ideal behavior and then start increases and show ideal behavior when they cross a line of ideal gas. Only they show ideal gas behavior at this particular value, not on at any other value. So we also plot another graph on the basis of Boyle's law, P versus V, pressure versus volume, or P is inversely proportional to V. We already discussed in Boyle's law. So according to this, the graph for ideal gas equation is dotted line and graph for real gases is red line. So only the red line cross at particular pressure and volume. At this pressure and volume it crosses the, or it lies, or it coincide with the line of ideal gas behavior. So only at this pressure and volume it show ideal behavior, otherwise at not any other pressure or volume it show ideal behavior. ਤੁਸੀਂ ਕੀ ਦੇਖ ਰਹੇ ਹੋ, at high pressure the ideal gas volume is this one, but for real gases the volume is a little bit high as compared to ideal gas at particular pressure. Same pressure ਤੇ ਜਿਹੜਾ calculated volume ਹੈ real gases ਦਾ ਉਹ ਜ਼ਿਆਦਾ as compared to ideal gas. ਇਸੇ ਤਰ੍ਹਾਂ when pressure decreases volume increases, so real gas ਦਾ volume ਜਿਹੜਾ ਉਹ increase ਕਰ ਰਿਹਾ with decrease in pressure more as compared to ideal gas. So ਇਸ ਇਹਦੇ ਅਕੋਰਡਿੰਗ ਸਾਡੇ ਕੋਲ ਜਿਹੜੀ ਆਈਡਲ ਰੀਅਲ ਗੈਸਿਸ ਨੇ ਦੇ ਸ਼ੋ ਓਨਲੀ ਆਈਡਲ ਬਿਹੇਵੀਅਰ ਐਟ ਪਰਟੀਕੂਲਰ ਪ੍ਰੈਸ਼ਰ ਔਰ temperature at a particular volume. Next we discuss about this term with the help of compressibility factor, which is denoted by capital Z, which is denoted by capital Z, or Z equal to PV upon nRT, PV upon nRT. So for ideal question, for ideal gases Z equal to 1, it means PV upon nRT equal to 1, or it is equal to PV equal to nRT. मीन्स ਸਾਡੇ ਕੋਲ ਜੇ Z ਦੀ ਵੈਲਿਊ ਔਰ ਕੰਪਰੈਸਿਬਿਲਿਟੀ ਵੈਕਟਰ 1 ਹੋਗਾ ਤਾਂ ਇਟ ਮੀਨਸ ਸਾਡੇ ਕੋਲ ਜਿਹੜੀਆਂ ਗੈਸਿਸ ਨੇ ਉਹ ਕਿਹੜੀਆਂ ਹੋਣਗੀਆਂ, ਆਈਡਲ ਗੈਸਿਸ ਹੋਣਗੀਆਂ. ਸਿਮਿਲਰਲੀ ਫॉर ਰੀਅਲ ਗੈਸਿਸ देयर आर टू वैल्यूज फॉर compressibility factor. Z have two values, either positive or negative. First one is Z is less than 1, negative deviation, and Z is greater than 1, positive deviation. First we discuss about a graph. We plot a graph between compressibility factor and pressure. You see this is black line for ideal gas equation, its value 1, Z value equal to 1. So at compressibility factor Z equal to 1. So it means at this level ideal gas behavior. But for hydrogen and helium, with the increase in pressure the compressibility factor value increases. So ਜਿਵੇਂ ਜਿਵੇਂ ਅਸੀਂ pressure increase ਕਰ ਰਹੇ ਹਾਂ ਤਿਵੇਂ ਤਿਵੇਂ ਹਾਈਡਰੋਜਨ ਤੇ ਹੀਲੀਅਮ ਦਾ ਜਿਹੜਾ ਫੈਕਟਰ ਹੈ compressibility factor ਉਹ increase ਕਰ ਰਿਹਾ more than 1 है. For other gases when we increase the pressure, for example for carbon dioxide, first it decreases and at a near about a 600 bar pressure it crosses the ideal gas behavior, but at this point it show ideal behavior, but at below it show a negative deviation, at high it show a positive deviation, but only at this pressure it show a ideal behavior. Similarly for methane gas, it first decreases with increase in pressure then increases. Similarly for oxygen it first decreases and then increases. Similarly for nitrogen it's very close, first it little bit decrease, but and at particular level or more than 200 bar pressure it also crosses the line of ideal gas behavior, or more than 1 value for compressibility factor. So according to this graph we conclude there are two observations. Z is less than 1 means negative deviation. It means those gases who show negative deviation first with increase in pressure, it means these gases are more compressible than expected from ideal behavior. मतलब कि ज़्यादा compressible होंगे जिन्ना दी compressibility factor Z less than 1 or negative deviation. So at low pressure they are highly compressible in nature, but at high pressure they are less compressible. For example nitrogen, oxygen, methane, carbon monoxide or carbon dioxide, they are more compressible at low pressure but less compressible at a high pressure. Another observation is Z is greater than 1, it is positive deviation, so the gas is less compressible than expected from ideal behavior. Means ਜੇ ਸਾਡੇ ਕੋ Z ਦੀ value greater than 1 it means ਜਿਹੜੀਆਂ gases ਨੇ they are not easily compressible. So it means Z is always greater than 1 for hydrogen and helium, it means they are less compressible in nature. So this is a factor compressibility factor, which determine or tells us which gas is easily compressible or which are not easily compressible in nature on the basis of their value. If Z is greater than 1, it means gases are less compressible than from ideal behavior, but if Z is less than 1 or a negative deviation, it means gases are highly compressible at low pressure, but at high pressure they are less compressible. So another factor which we discuss, that is effect of temperature. The deviation from ideal behavior become less and less with increase in temperature. मतलब कि ਜਿਹੜੀ डेविएशन ਆ ਸਾਡੇ ਕੋਲ from ideal behavior ਉਹ decrease ਹੁੰਦੀ ਜਾਂਦੀ ਹੈ with increase in temperature. So let us we plot a graph between PVM, it's a molar volume, versus P for nitrogen gas at different temperature. So let us see, we plot a graph for at different temperature T1, T2, T3 and T4, PV versus pressure, PV versus pressure. So at T1 ਤੇ ਸਾਡੇ ਕੋਲ deviation ज़्यादा show ਹੋ ਰਹੀ ਹੈ, but when we increase the temperature from T1 to T2 यही deviation ਹੋਰ decrease होगी. When we increase the temperature from T2 to T3 वही deviation ਹੋਰ घट गई, near about ideal gas behavior ਦੇ ਆ ਗਈ, ਕਿਉਂਕਿ ਜਿਹੜੀਆਂ dotted lines ਨੇ that show ideal behavior, means PV ਦੀ value constant value ਨੂੰ show ਕਰੀਏ. But when we increase temperature from T3 to T4 it near about constant value. It means ਸਾਡੇ ਕੋਲ when we increase the temperature the gases show less deviation from ideal behavior. So the temperature at which real gas obey ideal gas laws over an appreciable range of pressure, मतलब at particular pressure the temperature at which real gas obeys ideal gas behavior or gas laws, that is called boil temperature or a boil point. So boil point for nitrogen is 59 degrees Celsius and for hydrogen it's a minus 165 degrees Celsius. If you have any doubt up to here you can call me. Thank you.